Hello students, this is a fourth lesson, okay, in vectors. So I'm uploading short lessons, short videos, so that you can watch them at a short interval of time. Then later on, as I said, I will combine all of them and make one full video for the vectors. I have completed complex numbers, so I will be very shortly, I will be uploading the full chapter of complex numbers, okay? So you can watch it, right? So until now in complex numbers, in vectors, we have studied directed line segment, vector notation, how to write vector, addition of vectors, zero vector, subtraction of vectors, okay? Then scalar multiple of a vector, magnitude of a vector also we have seen. Magnitude means the length of the vector or size of the vector. And yesterday I taught to you vector in space. But listen to me, yesterday while compiling that video, I realized that there was a small mistake in labeling. All other things are correct. This 3 and 2 are wrong. Okay. So 3 should be here because 3 is x component and 2 is y component. Okay. So I will correct it today so that if you have any confusion, you should clear it, because 3 is x component, right? And 2 is y component. So 2 should be the height and 3 should be the width of OM, okay? And here also I should write OM is 3 and PM is 2, okay? All other things are correct. See, I wrote them in correct order. First 3, then 2. And the final vector is also correct, okay? Okay then. So let us start today's session. Yeah. So today, yesterday's one question was remaining. So I'll solve that and then we will proceed. Okay. Find scalar A, B and C such that 2 times this, okay, 2 times 103A is equal to B, C minus A, C minus 1 and 2 are equal to each other. So by equating components we can get them. So 2 times means I will multiply by 2. So 2 into 1, 2, 2 into 0, 0, 2 into 3A, 6A, okay, is equal to B, C minus 1 and 2. So equating components, we get, I will equate the components. So I will equate x component is equal to x component. So 2 is equal to B. Then y component is equal to y component. So 0 is equal to C minus 1. And z component is equal to z component. 6A is equal to 2. So therefore, A is from the third component, A is 2 divided by 6, which will be 1 over 3. B is from the first place, B is equal to 2. And from second place, C is equal to 1. So like that I got values of A, B and C. Okay. So A is 1 by 3, B is 2 and C is 1. Look here. From this I got B, from this I got C, and from this I got A. Okay, 2 divided by 6 will give me 1 by 3. So I hope you understood this, right? Then which one I should do? Okay, let me do B also, because there are 3 unknowns, and I will copy it on the next page. Yeah. So this will imply, I will multiply and write So by A I will multiply 1, by A I will multiply 1. So A and 0, it will be A 0 plus by B I will multiply 2. So 2B, this will remain 0 minus B. So 2B 0 and minus B. Then by C I will multiply 0. So 0, 0, C into 1, 1, C, and C into 1, C. So 0, C and C is equal to minus 1, 3, 3. Okay. So I will collect them together on the left hand side. So respective components I should add. A with 2B with 0. So A plus 2B plus 0. First component. Second component will be A plus 0 plus C. And the third component will be 0 minus B plus C is equal to minus 1, 3, 3. Okay. Is that clear to you? Yeah. So here we will equate the components again. Equating components, we will ignore the 0. Equating components, we get, look here, this component is equal to this component. So A plus 2B is equal to minus 1. Then the middle one, Y component, is equal to the Y component. So A plus C is equal to 3, right? And the third component, minus B plus C, is equal to 3, right? Okay, let me label them as 1, 2, and 3. Okay, I'll do the rest of the part here. Let me create a space here. Okay. Yeah. I will subtract from second, I will subtract third. So 2 minus 3 gives so when I subtract A minus of minus B, look here, I will subtract them. So this sign will change. This will be minus. This will be minus. So this will get cancelled. This will also get cancelled. 0, 0. And this will be A plus B is equal to 0, right? This is our fourth equation. I will write first with it because it is also in terms of A and B. Now, when I subtract, okay, so A and A will cancel. The here will be minus B and here will be plus 1. Okay, this will cancel. Here I am going to get minus B is equal to 1. So minus, let me write that sign with red, minus minus plus. Okay, now A and A will cancel. So 0. Then B minus 2B will give me minus B is equal to 1. So therefore B is equal to 1 minus 1. So I got the value of B. I will put it in fourth. From 4, A plus B. Plus B means minus 1 is equal to 0. Look here. In this equation I am putting the value. Okay, the value of B minus 1. So therefore A is equal to 1. So I got the value of A also. Now I'll put that value in second. From second. So in second equation, in this equation, I am going to put the value of A so that I can get C. So A plus C means 1 plus C is equal to 3. So C is equal to 3 minus 1, 2. So like that, I got all the three values, okay? A is 1, B is minus 1, and C is 2. So I hope you understood this. Yeah, it was not difficult, right? Okay then. Now properties of vectors in space. So look at the properties. A plus B is equal to B plus A. It means it is commutative. Commutative means you can change the order. You can bring the second term in second vector in place of first, and first can be in place of second. Okay. Then it is associative also. It means if A plus B is added to C, it is same as B plus C added to A. Okay. Then additive identity, as we have in numbers 0, here also it is a 0 vector. So vector A added to 0 vector will be same as 0 vector added to A, which will be equal to only vector A. So adding a 0 vector will not affect any vector, okay? Then additive inverse. In A, if we add negative of A, or in negative of A, if we add A, it is going to give us a 0 vector. So this is called additive inverse, okay? Because when we add both of them, it gives us 0. Then distributive property, scalar over the addition of vectors or subtraction of vectors, we can do it. So k into vector A plus B is equal to k into vector A plus k into vector B. Yeah, I hope you understood that, right? Then modulus of k into A, it means length of Ka is equal to modulus of k, absolute value of k, into mod of vector A, means length of vector A. Mod means magnitude. It gives us the magnitude, right? So length of k into vector A is equal to absolute value of k, means positive value of k we have to take, because in the left hand side also we have absolute value. So we have to put absolute value into the magnitude of A. That will give us the resultant vector, okay? So it means to find the magnitude of k into A, where k is a scalar, we can keep k aside, absolute value of k, into magnitude of A, okay? Then if x plus A is equal to B, vector x plus vector A is equal to vector B, then x is equal to vector B minus vector A. Similarly, if k into x is a vector equal to A, where k is not equal to 0, then x is equal to 1 by k times A. So as we divide in simple equations, like that we divide in vectors also by a scalar. Remember that by vector we cannot divide, okay? We cannot divide by a vector. There are multiplication rules of vectors, but there are three specific rules, okay? One is dot product, second is vector product, and third is scalar triple product, okay? But they are specific. They are not as simple as we multiply real numbers, okay? So be careful about it. There is no rule of division in vectors, okay? There are multiplication rules, 3 multiplication rules, but they are specific. We cannot use them like real numbers, right? Okay. Now example based on these properties, okay? What we have seen here, same properties we are going to use and solve the example, right? So example 12 tells us, suppose A is given, okay? Vector A is given, and this vector A is equal to minus 1, 2, 3. Vector B is equal to 2, minus 2, 1 in component form. Find x such that 2A vector 2 into vector A plus vector x is equal to vector B. Okay, the first one we will solve. So 2 vector A plus vector X is equal to vector B. So as we have seen, I can write vector X is equal to B minus 2 times vector A. And this is going to give me vector B. So I'll write the vector B in component form, 2 minus 2, 1, minus 2 times A. A is minus 1, 2 and 3. Okay. Now after simplifying, so this is going to give me 2 minus 2, 1, minus by 2 I will multiply inside each one of them. So 2 into minus 1 minus 2, 2 into 2 4, 2 into 3 6. Okay. So finally I will combine them. 2 minus of minus 2 will be plus 2, minus 2 minus 4 and 1 minus 6. Okay. So this will give me 2 plus 2 4, minus 2 minus 4 minus 6 and 1 minus 6 minus 5. Okay. So like this I got vector X. Okay. This is the answer for vector X. Now I will solve B here itself. Part B. So 3x vector X minus a vector A is equal to 2 times vector B. So 3 times vector X is equal to minus A can be taken there. It will be plus vector A plus 2B. Okay. And by 3 I can divide. So vector X, let me keep 3x now here. First let me add these two vectors. So A means minus 1, 2, 3. Okay. Then plus 2 times B. B is 2, minus 2, 1. So when I combine them, I will now directly multiply. Look here, 2 times 2, 4. So minus 1 plus 4. Then 2 minus 2 times 2, 4. So 2 minus 4. Plus of minus is minus. Then 3 plus 2 times 1 is 2. So 3 plus 2. Okay. Okay. So this is going to give me plus 4 minus 1, 3. 2 minus 4 minus 2. 3 and 2, 5. So therefore now X I can write 1 by 3. Okay. I will divide it by 3. So 1 by 3 times this vector. So by 3 I can divide each component. So look here, 1 by 3 into 3 will give me 1. 1 by 3 into minus 2 will give me minus 2 by 3. And 1 by 3 into 5 will give me 5 by 3, right? So this is the answer for vector X. So what we have learned, that addition and subtraction of vectors will give us a vector. The resultant will be a vector. It will not be a real number or anything like that. Okay. Then the third one, also I will solve third one. Let me copy it there. Yeah. So from this, what can I do? I will keep this here, minus 2x is equal to minus a vector A, and this I will take there. So minus 2b, okay, vector B. Okay, now by minus I can divide minus 2, or just the minus sign I will change. So it will be plus A and plus 2b, because we know that since k into vector A, if it is like this, okay, then I can separate them k into magnitude of vector A. Like that also we can write. But here it is not required in this way. Anyway, So I have just multiplied by -1. So we can multiply by -1 everywhere. So I get all of them positive. Now A means vector A I have to write here. So vector A was -1, 2, 3 plus 2 times vector B was 2 minus 2, 1. So this will be -1, look here, -1 and 2 times 2, 4, -1 plus 4. Then 2 plus 2 times -2 will be -4. So 2 minus 4. And the third component 3 plus 2 times 1 is 2. So 3 plus 2. So this will be 4 minus 1, 3, 2 minus 4, -2, and 3 plus 2 is 5. So 2x is this one, 2 vector x. Now I will divide by 2. So therefore vector x is half of this vector 3, -2 and 5. Now each component can be divided by that. So 3 by 2, -1 and 5 by 2. This is the answer of x. Okay. So I hope you understood this. Yeah. Okay, now vector between 2 points. Look here. If we have 2 points, see here, A is a point, A1, A2, B is a point, B1, B2. So these are the 2 points. Now we want to find this vector AB. Okay. So to find vector AB, we already know the triangle law of addition. It will be vector AO plus vector OB. Okay. So from the figure alongside, using addition law, we get vector AB is equal to vector AO plus vector OB, right? AO plus OB. Okay. Now AO is negative of OA, okay, plus OB. So it means OB plus OA, and they are given by small a, vector A, and small vector B. So negative of A, vector A, plus vector B. So this I can write as B minus A, and B means the components of vector B are B1, B2. So I can write it in component form B1, B2. I hope you understand. The coordinates can be converted to the component form provided your initial point is origin. Okay. Not in any other case. And vector A will be given by A1, A2. Okay. Because we have here A1, A2. So it will become A1, A2. Okay. And then we can bring them together. So therefore AB is equal to B1 minus A1, B2 minus A2. Okay. So this is the resultant vector. Okay. This is called displacement vector of B relative to A. This is displacement vector of B relative to A. So actually what we are writing? It is the vector of B relative to A. A is the initial point here. Okay. So displacement vector of B relative to A means where it is getting displaced. Okay, that is given by B1 minus A1, B2 minus A2. So if you have 2 points in plane or in space, then what you can do, AB will be coordinates of B minus coordinates of A in component form you have to write, and that gives you the displacement vector of B relative to A. Okay, so let us solve some questions based on it. Okay, now this question number 13 is so question number 13 says M and M is having coordinates 4, minus 2, minus 1, N having coordinates minus 1, 2 and 0. Find the displacement vector of M relative to N. So N, M we have to find. Okay, first one A. So displacement vector of, I will write it in short, displacement vector of M relative to A is equal to, I should write N, relative to N is NM, vector NM. Okay, and for vector NM, what we are going to write? The coordinates of M first. Okay, this is first and then this is second. So when we write it in component form, so the x component of M first minus x component of N. Okay, so 4 minus of minus 1, then y component minus y component, so minus 2 minus 2, and then z component minus 1 minus 0. So finally I get 4 minus minus plus 1, 5, minus 2 minus 2 minus 4 and minus 1. Okay, 5 minus 4 minus 1. This is displacement vector of M relative to N. Okay, now B is displacement vector of N relative to M. So B will be displacement vector of N, okay, relative to M. So it will be now different. Relative to M, so M will be first and N will be second component. So now while writing, how we write it? We write this first and this will be the second. So first here, second here, okay, N minus M. So N is minus 1, minus 4, let me write all the N components, minus 1, 2, 0. Then M components, let me write, no need of negative sign here. Later on it is going to be negative, so 4, minus 2, minus 1, okay. 4 minus 2 minus 1, right? So this is going to give me minus 1, look here, minus 1, minus 4, then 2 plus 2, because look here, this 2 and minus of minus 2 will be plus 2, so 2 plus 2. And the third component 0 plus 1. Look here, 0 minus of minus 1 will be plus 1, right? So I hope you understood this. So minus 5, 4 and 1. So look here, exactly the change in sign is there because the direction has changed. First was 5 minus 4 minus 1. Now this is minus 5, 4 and 4, 4 and 1. So it's exactly negative of the first vector, okay. Now the distance between M and N, okay, distance between M and N will be the magnitude of Mn. Yeah, it can be from N to M or from M to M because it is the distance only. So I will find Mn only, magnitude of Mn will be the square root of, you already know, x component is square. I am taking from Mn the second vector, 4 square, 1 square, right? So it will be 25 plus 16 plus 1. Okay. So 42. Okay. So this is 42 units, right? So I hope you understood this, right? How I got this. First I found displacement vector of m relative to n. So I should write nm, look here, the other way I should write, this should be first, this should be second. And here displacement vector of n relative to m, so this should be first, this should be second. That way I wrote them. And then while writing their component vectors, first we should write n components of n, and then we should write components of n, then m. Okay, that gives us the answer, right? Okay, so I have finished that question there. Now next question says, consider the point a minus 1 3 and b 3k. This is in plane, two-dimensional geometry, right? So find AB, vector AB I have to find, and the magnitude of AB, right? So these two things I have to find. Okay then, so let me start here. A part. Now find AB. I have to find AB, right? And vector AB, magnitude of AB. So first vector AB. So it will be OB minus OA. I already gave you this, that in terms of position vector, you start with this and end with this, right? So OB in component form will be 3k minus OA will be minus 1 and 3. So which is going to give me 3 minus minus plus 1 and k minus 3. So it is equal to 4 and k minus 3. Okay, 4 and k minus 3. Therefore, now magnitude of AB. So as you already know, x component is square plus y component is square, k minus 3 is square. So it will be 16 plus k minus 3 square. I will keep it now as it is. This many units are there. Then B part says, given that A and B are 5 units apart. So what is given? Their magnitude is given. So given magnitude of AB is equal to 5. Look here, they have given here in B part, magnitude is 5, okay, 5 units. Find two possible values of k. So we are going to get two possible values because there is bracket square. So therefore square root of 16 plus k minus 3 square is equal to 5. When we square both sides, so it will be 16 plus k minus 3 bracket square is 25 because squaring this, right? And then 16 will go there. So k minus 3 bracket square, 25 minus 16, which will be 9. And I will solve this here so that everything is in front of you. Okay. So k minus 3 bracket square is 3 square. Therefore, k minus 3 is plus minus 3, right? Because when we take the square root, it can be plus and minus 3, okay? You can do it this way, or you can factorize them, okay? You can open the bracket square and then factorize, okay? In any way you can do that. So therefore, k is equal to 3 plus minus 3. So therefore, k is equal to, with minus sign, 3 minus 3 will be 0, or k is equal to 3 plus 3, 6. So look here. 3 minus 3 will be 0, or 3 plus 3 will be 6. Okay, so 0 or 6, these are the two values of k. Okay, what the next part says, show by illustration why k should have two possible values. Okay, so look here. I'll show you by illustration on the next page. Let me draw a circle. Yeah, and this circle, sorry, let me take, yeah, y axis, x axis, and origin, and this circle has, a we will take here, -1, what was a? -1 and 3, okay, and b will be on this circle somewhere, so it should be at a distance of 5 units. Look here, this circle has a radius of 5 units, right? 5 units radius. Now from here 5 units here or 5 units there, okay, that can be given by a line, by a chord, right? So on this chord, yeah, so let me call it, this is A, this is B, 3 comma K1, and this can also be B, 3 comma K2. Okay, so one of them, actually it is at the origin, because the y component, the y component is 0, the value of k is 0, so I should have drawn it on the x-axis. So let me erase this diagonal, let me draw like this, and then somewhere here it can be, okay, B and B, it will be 3 and K2, and K2 is 0 here, and this will move there. Okay, now it is correct. Okay, so the radius of the circle is 5, so 5, 5, 5, because this is an isosceles triangle, so in the isosceles triangle we can get two values of B. Okay, both will have same distance from A, right? So I hope this is clear to you, right? Now next question, question number 15, right? So now in this question, what is given? A quadrilateral has vertices A 1, 2, 3, B 3, minus 3, 2, C 7, minus 4, 5, and D 5, 1, 6. Find AB, find DC. So we already know how to find AB. So vector AB will be vector OB minus vector OA, right? So I will write the vector OB in component form. Look here, this is B. So 3 minus 3, 2, minus OA. So OA is this 1, 2, 3. So this is going to give me, now I will directly simplify, 3 minus 1, 2, minus 3 minus 2 minus 5, and 2 minus 3 minus 1. So look here, 3 minus 1 is 2, then minus 3 minus 2 minus 5, and 2 minus 3 will be minus 1. Okay, so 2 minus 5 minus 1 is AB, and DC also I have to find, vector DC. So vector OC minus vector OD. Okay, in terms of position vector we write like this. So look here, OC, the coordinates of C we will write because it is starting with O. Okay, so we can use coordinates as components. 7 minus 4, 5. And OD is this 5, 1, 6. So this will be 7 minus 5, 2, minus 4 minus 1 minus 5, and 5 minus 6 minus 1. So I'll repeat again, 7 minus 5, 2, then minus 4 minus 1 minus 5, and 5 minus 6 minus 1. Okay, so 2 minus 5 minus 1. So we got both the vectors. Now B part says, what can be deduced about the quadrilateral ABCD? Look here, AB and DC. If you draw a cyclic quadrilateral, let me draw cyclic quadrilateral. Oh, why it is not completing? Yeah, so actually it is not a rectangle. Anyway, this is the one, A, B, C, D, ignoring where according to their position. So we are ignoring that. Now AB we got here and DC is this. Now look here, both the vectors are same. So when vectors are equal, they are parallel to each other, as well as their length is also equal. So since vector AB is equal to vector DC, so this implies magnitude of AB is equal to magnitude of DC, and AB is parallel to DC. Unless they are parallel, we cannot write them equal to each other. So they are parallel and equal, the opposite sides. Therefore, the other pair will also be parallel and equal. So this implies ABCD is a parallelogram. ABCD is a parallelogram. Okay. So like that we have proved that ABCD is a parallelogram. Okay. So okay then, with this we will end this lesson. Yeah, I hope you enjoyed this lesson. Okay. So if you like this lesson, then please like, share and subscribe my YouTube channel. You can contact me on my email ID or you can contact me on my WhatsApp. The link of the PDF of this explanation is there in the description of this video. Okay, this is vector 4. Okay, then bye for now.